how to find determinant of triangular matrix. So first, let's recall on triangular matrix from chapter 1. There are two types of triangular matrix. Number 1, upper triangular matrix. Number 2, lower triangular matrix. Upper triangular matrix when all entries below the main diagonal are 0. For lower triangular matrix when all entries above the main diagonal are all 0. So to find the determinant for upper triangular matrix, A11 multiply by A22 multiply by A33. The same goes for lower triangular matrix. To find the determinant, A11 multiply A22 multiply A33. So in conclusion, to find determinant of triangular matrix, multiply the entries from the main diagonal. For example, when we want to find the determinant of these matrices, first we have a 3 by 3 matrix. From the matrix, we can see that this is a lower triangular matrix. All the entries above the main diagonal are all zeros. So to find its determinant of matrix A, multiply all entries from the main diagonal. 5 multiply by -2 multiply by -2. So we get 20. Second example, here we have matrix B. Matrix B is 4 by 4 matrix. We can see here that all the entries below the main diagonal are all 0. So this is upper triangular matrix. To find determinant of matrix B equal 2 multiply by -2 multiply by 2 multiply by 6, which equal to -48. We can also find the determinant of matrix by using ERO, which is elementary row operation, or ECO, which is elementary column operation. So to find determinant, either you apply ERO or ECO. Reduce the matrix by row or by column. Bear in mind, you must change the first entry A11 to 1. Okay, for example, the first matrix, look at the first column, 1, 0, 0. So X can be any values. Second matrix, okay, the first entry is 1. Okay, X can be any values. There are 3 operations involved in ERO or ECO. Okay, number 1. If we exchange between 2 rows or exchange between 2 columns, for example, we change R1 and R2, or we change column 1 and column 2. So to find determinant A equal -1 multiplied by determinant B. Second operation, when we multiply a constant by row or column. For example, 2 multiplied by row 2 to change row 2. Or 3 multiplied by column 3 to find determinant of A equal 1 over K multiplied by determinant B. Okay. If K here is 2, then multiply by 1 over 2. If k here is 3, then multiply by 1 over 3. And the last operation is when we multiply a row or column by constant and then plus with another row or another column. And then to find determinant A equal 1, multiply by determinant B. For example, now we want to find determinant of this matrix by using the combination of elementary row operation and elementary column operation. So, our first target is to change the first entry, 7, into 1. So what we can do here is that we can exchange between column 1 and column 3. And remember that whenever we exchange between row or between column, we must multiply the matrix by -1. Okay, multiply by -1 and then exchange column 1 and column 3. Our next target is that we want to change -1 into 0. So what we can do is that R1 plus R2 to change R2. And when we do addition operation, we must multiply the matrix by 1. One plus -1, 0. 3 plus 0 is 3. 7 plus -6, 1. Our next target is to change 1 from the third row into 0. What we can do is -R1 plus R3 to change R3. And again, when we do an addition operation, we must multiply the matrix by 1. -1 plus 1, 0. -3 plus -4 is -7. -7 plus 2 equal -5. Can you guess what is our next target? So our next target is to change -7 into 0. So what we can do is that we can multiply the second row by 7 over 3 and plus with the third row to change third row. The equation is like this. And do not forget that whenever we do an addition operation, always multiply the matrix by 1. So, here we have an upper triangular matrix. Therefore, we can find the determinant by multiplying all the entries in the main diagonal. So, determinant of matrix A equal 1 multiplied by 1 multiplied by 1 multiplied by -1 is -1. Multiply by all the entries from main diagonal. And our final answer is equal to 8. Let's do another example to find the determinant of a matrix by using elementary row operation and elementary column operation. So from this matrix, our first target is to change 6 into 1. So we can exchange row 1 with either row 2 or row 3. And always remember, when we exchange between rows or exchange between column, multiply the matrix by -1. Next target, we want to change 6 to become 0. And remember, when we do any addition operation, we must multiply the matrix by 1. Next, we want to change 1 into 0. And remember, when we do an addition operation, we must multiply the matrix by 1. The last entry that we want to change is -1 to become 0. And again, remember, when we do any addition operation, multiply the matrix by 1. Here we can see that we have an upper triangular matrix. So we can find the determinant by multiply the entries from main diagonal with all the constant in front of the matrix. So determinant of matrix B equal 1 multiplied by 1 multiplied by 1 multiplied by -1, which equal to -1. And then multiply with all the entries from the main diagonal. Our final answer equal to -45. Next example, solving matrix determinants for cases when no definite values are given for all entries. Here we have the determinant of the first matrix is equal to -2. We are given another matrix and we need to find the determinant of this matrix by using the determinant of the first matrix. So we need to reduce the second matrix until it is similar to the first matrix. First operation that we can do is that multiply the second column by -2 plus first column to change the first column. -2 multiplied by b, we have -2b plus column 1. So -2b plus 2b plus a equal a. Next, -2 multiplied by -5e. We get 10e plus c1 plus -10e minus 5d equal -5d. Next, -2 multiplied by h, we get -2h plus c1 2h plus g equal to g. Next, multiply the third column by -1/2 to change column 3. And when we multiply any column or any row by a constant, we must multiply by 1/k. -1/2 multiplied by -2c, we get c. -1/2 multiplied by 10f, we get -5f. -1/2 multiplied by -2i, we get I. And finally, we want to change all entries from the second row. We can multiply second row by -1/5 to change R2. So from -1/5, we take -5. -1/5 multiplied by -5d, we get d. -1/5 multiply -5e, we get e. -1/5 multiply -5f, we get f. And then for the final answer, we know that the determinant of this matrix A, B, C, D, E, F, G, H, I is equal to -2. Multiply -5, -2, 1 by -2. So the final answer is -20.